Let's look at some interesting cases here regarding horizontal and vertical lines. Think about the equation of the line y equals 3. Notice that this is missing some information we had on previous equations. If you notice that there isn't an x in here, you're very perceptive. What we're seeing is really I have 0 x's and a constant of 3, or a positive 3. So if you think about what's happening, if I create an input-output table, and maybe x is 1, 2, 100, no matter what I plug in for x, 0 times that value will always come out to 0, leaving me with only a 3 for y. This is why I'm seeing in my equation y equals 3. What do you think that looks like on the graph? Let's go ahead and draw the coordinate plane here. I have an x-axis, y-axis. No matter what my input is, output is always 3, so I can think of the point 1, 3, which is here, 2, 3, 3, 3, 103. No matter what, my points are all going to lie on the coordinate y equals 3. So this is a special case where when I don't have an input value that I can see in my equation, my output's always 3. I have a horizontal line through 3, forever and ever and ever. You're probably wondering, well, is this a function? It looks a little bit different from what we've seen as far as using diagonal lines that either are sloping upward or downward, but yes, this is a function. Yes, this is a function. Even though we have these repeated output values, notice that each input still only has one output. For example, 1 is going to 3, 2 is going to 3. I don't have any input values going to different output values. My horizontal line is a function. You might be wondering, well, isn't everything we've seen so far a function? Most of what we've seen is a function. Let's look at an example of a non-function. Let's graph the equation x equals 2. Let's get a darker color here to see against the graph. X equals 2. Well, this looks a little bit different as well. Now I'm not seeing a y. I'm going to hold off on making a table for a moment, and let's just think about what this looks like on the coordinate plane. If my input x is always 2, what's my output going to be? Well, what this is saying, if I think about an input-output table, x is always 2, forever and ever and ever. X is always equal to 2. So my y values are going to be everything that go with an input of 2. In other words, if I count my graph 1, 2, 3, I actually have a vertical line through 2, because this is the only place where x is equal to 2 forever and ever and ever. I can say I have the coordinate 2, 0, 2, 1, 2, 2, a million. X is always 2. This is definitely not a function. As you can see, I really have one input value going to an infinite amount of output values. This line goes on forever in both directions. So I could say if I was making this in a map, 2 would go to 1. 2 would also go to 2. 2 would also go to 1,000. I have one input to an infinite amount of output values. A vertical line is going to be my linear equation. I do have a line, it's linear, that is not a function. Now that we've reviewed graphing using input-output tables, let's look at a couple special cases here. We're going to look at graphing horizontal and vertical lines. Vertical lines. Let's think about the graph y equals 3. Notice this looks a little bit different from what we've graphed before. I don't see any x value. What this is really saying is there aren't no x's in this. We really are talking about 0 x's plus 3. Let's think about what that looks like on the graph. drawing my x and y axis, 0x plus 3. If we were to make an input-output table for this, no matter what x is, 0, 1, 2, 100, whenever I plug in my input, it's always going to become 0. 0 times any value is 0, leaving me with 3 each time. So in other words, y is always equal to 3, and I probably should have extended my y-axis up a little bit further. No matter the x-coordinate with y being 3, you can think of it, I have a point at 0, 3, 1, 3, 2, 3, no x's. Most of what we've looked at to graph or work with so far has been in this format. For example, y equals 2x plus 1, where I have an equation with y on one side, a coefficient with x, and a constant on the other side. This form actually has a name called slope-intercept form. And we'll see very soon why it's called this. This is called slope-intercept form. We also can call it function form. Function form. Because we can easily see when we plug in an x and get out a y, I have an input giving one output, we can see that we do have a function. Except in that vertical line case. Sometimes we'll see equations given in a format that looks like this. X plus 2y equals 6. This is not in function form. When I have the two variables on the same side and a constant by itself, this is called standard form. Standard form. We can look, this is still a linear equation, but it's given in a different format. It's not solved for y, meaning y is not by itself as it is in the top equation. Now we've learned the algebra to be able to solve for y, which we'll do in a moment. Slope-intercept form or function form and standard form. Depending on the question as we work through this unit, we'll see that sometimes it's easier to use standard form, sometimes it's easier to use function form. Right now, function form is easier when we graph because we can put in an input for x and directly get out an output. If I was to do that here, I would need to plug in for a y and do some stuff, do some algebra to get out an x. So I'm going to make my life a little bit easier right now and solve this equation for y. What I can do is subtract an x from both sides. Let's start to get the y alone. X minus x, that'll cancel. That leaves me with 2y equals 6 minus x. Or if you prefer to write it out, I can say that 2y equals negative x plus 6, if you prefer to see the x written first. Next step, I want to get the y by itself. If you were thinking, well, I need to divide both sides by 2, you're correct. When I divide both sides by 2, I'm dividing every single term by 2. My 2's cancel on the left, leaving me with a y. 6 divided by 2 is 3. Don't forget your minus sign. And x over 2, we usually like to write that instead of x divided by 2 as 1/2 x. Although you don't have to. X over 2 is appropriate as well. Using the same algebra steps in my other version, it would also look like negative 1/2 x plus 3. Most people just like to look at this format. Both of these are in function form. The second one is specifically in slope-intercept form. Slope-intercept. That's a very specific type of function form that always has the y first, and then my x term, and then my constant. If we wanted to go a step further and now graph this, you can see that both of these are set up to very quickly plug in an x and get out a y.